They're cosmic shortcuts that put alien worlds practically on our doorstep. But how would we actually build one? And how would we use one? Travel by wormhole requires exotic technology and the courage to jump into the unknown. Our planet is riddled with passageways. We regularly travel through strong, stable tunnels cut through massive mountains.
Well, here we're entering a nice, solid tunnel. It's made of, looks like concrete and reinforced steel. Very solid, a reliable means of transportation. I drive my car in, I'm going to come out, I know what's happening at all times.
Physicist Hsu is fascinated by the concepts of stability and instability, be they in the stock market,
Sell,
in real estate values,
long,
or in space-time wormholes.
One of the fundamental properties that we look at in physics when we look at a particular system is whether that system is stable or unstable. An example would be a pen, which is balanced like this. It might be okay when it's exactly balanced, but even a slight bump will send it into a drastically different state. We decided to look at whether one could build a wormhole that had nice properties, such as its behavior is predictable and it's stable. Those are two criteria you'd like to have for a real wormhole.
The rules of building wormholes start with Einstein's theory of relativity, which tells you how to bend and shape space as if it were a flexible sheet.
Imagine this sheet of paper, and imagine that you're an ant living on this sheet of paper. If you want to travel from this point to this point, you might have to walk all the way from here to here. But if the paper were curved, the long way around would involve walking all the way around the paper like this. But you can imagine that there would be a little tube connecting this point directly to this point, and the ant could just slip through.
That's a wormhole.
Wormholes in science fiction have gaping entrances that a starship can dive into. But those two-dimensional renderings gloss over the true architecture of wormholes.
In this two-dimensional analogy, the opening of the straw is just a circle. But because we live in 3 dimensions, the opening of the wormhole would actually be like the interior of a bubble.
This is what the mouth of a real wormhole might look like, if they're lurking somewhere out there in space. But Stephen wondered if we might be able to build our own from scratch. A cosmic engineer would first create 2 mouths and connect them. Then he would drag one of the mouths light years away. But the tunnel between the 2 mouths is not part of our space and could remain very short. It's a simple idea, but the vast amount of negative energy needed to keep the wormhole's mouth and tunnel from collapsing is tricky stuff to control.
It's very challenging to stabilize a wormhole.
Come on, Carrie, you don't know.
Wormholes,
I don't care
as far as
about
we know from general
wormholes.
relativity, require this kind of special negative energy exotic matter.
So we can go to
The
different
question is whether
planets.
that matter
Check it
itself
out.
can be stable.
Stephen crunched the numbers on how negative energy would react with normal matter on the fringes of the wormhole to discover whether they could coexist in a stable way.
And we've proven mathematically they're unstable. That would be a very dangerous device to use, because once you bump it a little bit, the entire device could just fall apart. If I try to get into an unstable wormhole, it's like trying to put my finger into this bubble. It'll just pop.
The negative energy needed to keep a wormhole open is inherently too unstable. A man-made wormhole would collapse the instant someone tries to step inside. But there might be another way. Not by using cosmic shortcuts that we have built ourselves, but by searching for microscopic ones that could be hiding all around us. Just as empty space is fizzing with microscopic pulses of energy, Some theorists believe it could also be riddled with microscopic holes.
There could be quantum wormholes that are just left over from the Big Bang, or at very, very short distances, you could have little fluctuations where space-time just connects to itself in a funny way, and that would be a quantum wormhole. If they just happened as a little fluctuation, it would be incredibly tiny, like 10 to the minus 35 meters.
Microscopic quantum wormholes are quantum fluctuations in space that perpetually appear, disappear, and reappear again. Since we don't have to construct their portals, Stephen suspects they might be safe to enter. But before you try jumping into one, be aware there's a catch.
Quantum mechanical things are fuzzy. They're intrinsically random and unpredictable. So if we were in a quantum wormhole, we might be shaking around and we wouldn't quite know where we're going to come out. You wouldn't want to get into a tunnel that might end in the bottom of the Pacific Ocean or on a mountaintop that you didn't want to be on.
Quantum wormholes have no estimated times of arrival, and your destination is unknown.